Alright, hello Trig. So, today we're looking at derivatives. And in the last video we were looking at how to find a slope at a point if it's not just, a straight line. Today we're looking at what happens if we want to find that everywhere. So what we're going to do is we're going to take the same formula we were using last time. We're going to it'll take that f of x plus h minus f of x over h, but instead of doing that with a point, we're going to do that with the whole thing. And we're going to start with one that you probably already know the slope of, because if we've got a 6x minus 2 here, the slope of that should just be what? Hopefully you said 6. Because this is a nice straight line, so we know our slope should end up with 6. So we're going to take f of x plus h. So we're going to say we've got 6x plus h minus 2 minus, and again, watch out for when I subtract the whole thing, 6x minus 2 over h. So we've got the x plus h that we plugged in instead of x, and then just that f of x. Okay, so we're going to distribute that. So we got a 6x plus 6h minus 2 minus that 6x minus, and then a negative, it gives us a plus that 2. And the nice thing is a lot of this is going to cancel, because this 6x and this minus 6x are going to cancel. This minus 2 and plus 2 are going to cancel. So now I got 6h over h, and those h's are going to cancel, which is 6. So the derivative of this, which we are going to write as f with a little prime, which should go this way, so f with a little apostrophe, so f prime of x is just 6. So that's a little note, our little notation there for a derivative. So that's the derivative of that function. So that's our slope everywhere. Now, that one you probably knew off the top of your head, because that's just a line with a slope of 6. Now we're going to do one that's not quite so nice. So let's say we got this. This one's a parabola. So this time we're not going to end up with the same slope everywhere, so it's going to be a little bit more complicated. But we're still doing the same thing. So instead of x here, we're going to have a 4 times an x plus h squared minus 6, and then minus this whole thing, 4x squared minus 6 over h. Alright, and watch out for order of operations. We're squaring this before we take it times 4, so we're going to have 4 times this whole thing, x squared plus an x times an h plus an x times an h, so plus 2xh plus h squared minus 6 minus a 4x squared minus and minus, so plus that 6 over h. And then we're going to distribute this stuff. So we got a 4x squared plus an 8xh plus a 4h squared, excuse me, minus that 6 plus that 6. I'm just going to cancel that out so we have a little bit more room here. So, and then minus this 4x squared. Now, nicely, this 4x squared and this 4x squared are going to cancel, and this is all over h. And then we're going to factor out an h. So on the top we've got there an 8x plus a 4h if we take out an h over h. These h's are gone. And same sort of thing as before, we're going to say that h is approaching 0, so this is also gone. So your f prime of x, or your derivative, is just 8x. Cool. Now, again, eventually, and I promise it's in the next section, we're going to get into some rules that we're not going to have to go through and do this every single time we want a derivative of something. But in order to get those rules, we need to do this first. Okay, let's do that. So let's say we got a fraction. Alright, so we've got a 6 over an x plus 2. So we're going to have a 6 over an x plus h minus 2 minus a 6 over an x minus 2. over an h. Okay, so in order to add fractions, we need a common denominator. So we're going to take this side times an x minus 2. We're going to take this side times an x plus h minus 2. And that's the over h. So we got a 6x minus a 12 on the top, minus this 6x. And watch out for this is minus this whole thing, so this is also a minus a 6h. And minus and another minus, so plus that 6 times 2 is 12. Over an x minus 2 times an x plus h minus 2 over h. Okay, which again looks messy, but a lot of this is about to cancel because we've got a 6x and a minus 6x that are going to cancel. I've got a plus 12 and a minus 12 that are going to cancel, so I've really just got a minus 6h over this stuff. So I've got a minus 6h, and that h and this h are going to cancel. So I've really just got a negative 6 over an x minus 2 and an x plus h minus 2, but we said that h is approaching 0, so I'm just going to call that another x minus 2. Now, if you leave it like that, that's fine. Just a heads up that if you double check that in the back of the book, it's probably going to have this instead. Same thing. So I don't particularly care whether you have an x minus 2 times an x minus 2 or an x minus 2 squared. Same thing. So we're going to do the same thing. We're going to plug in a square root of x plus h minus 5 minus a square root of x minus 5 over h. And then what we're going to do with that is we're going to take both the top and the bottom times an x plus h minus 5 plus an x minus 5 inside a square root. So we're going to do that on the top and we're going to do that on the bottom. So again, x plus h minus 5, should have left myself some more room there, plus a square root of x minus 5. So this says the same thing as that says. Okay, if you're having some trouble reading that. So these two are the same thing. We're multiplying by the opposite of this with a plus here instead of a minus. I just didn't quite leave myself enough room there. Okay, the reason we're doing that is once we FOIL this out, that's going to cancel out both of those square roots. So we'll have an x plus an h minus a 5, and then we're going to have this and this are going to cancel. So we've really just got a minus an x minus 5 there, and watch out for subtracting that whole thing, so that's a minus an x and a plus a 5, and that's all over h times this stuff. There we go. Okay. Which, again, doesn't immediately look a whole lot better, but some of it's about to cancel because these x's are gone. These 5s are gone. So I've really just got an h on top. And the reason I didn't go through and distribute that h is now we can cancel that h with this h, so the only thing left on the top is a 1. And now that there's only one h left, we can say that that h is approaching 0, so I've really just got a square root of x plus, minus, because it's minus 5. Minus 5 on the bottom, plus a square root of x minus 5. But that's really just 2 of that. So I'm just going to call this 2 square root of x minus 5. And that's your derivative of x. Alright, and again, in the next section we're going to be getting in some ways to do that without going through and doing this whole thing every time, because this gets messier if it gets even more complicated, so it's going to be nice to have some rules to go with this stuff, and that's what we're getting into in the next section. So for this one, just go ahead and do this, which is why, again, I didn't assign a lot of problems there, because these do get kind of long and kind of messy, and we're about to find a nicer way to do them anyway. So go ahead and check out the homework in the description, and I'll see you next time.